Assalamu alaikum warahmatullahi wabarakatuh. Dear students, so now we are in assignment number 2, problem number 3, narrating the problem. The problem is asking the programmer to write a program to count the number of not matching bits between the register CX and the immediate value AD6B in hexa. So problem is actually a simple problem, and we will go now into the board in order to show how can we put a design for the problem and how to solve it. For problem number 3 for the assignment number 2, we have actually a problem that as it is described in the problem, we will just narrate the wording, write a program to count the number of not matching bits between CX register and the immediate value, and it's provided actually an immediate value provided in the problem. This problem actually, in order we need to check whether the bits of the CX and some immediate value, where are the matches and where are the not matched. In digital logic design, we have learned that the bitwise operation that actually can compare between two bits is actually the XOR. So XOR is actually will provide or will give me an output 1 if the bits are not equal, and will give me 0 if the bits are similar to each other. So accordingly, and since the question is actually want to check about the mismatched bits, so I need to XOR between the CX and the value provided. So we can have here the code design. Step number 1 is to, first of all, I don't want to screw up or change the value of CX. So I may copy CX in other register for the comparison. In step number 2, I want to use or utilize the bitwise XOR between the value of CX and the immediate value A provided, which is in the example it was A, D, whatever. Okay, it makes actually no difference. Any value he will give me, I can just use the XOR. So that means each bit that are not equal or not matched between the CX and this number, the XOR will give it or will give the output as a 1. If they are matched, it will give me a 0. Okay. Right now, I will end up of register, whatever the register is. As you mentioned, we copy CX. Okay. Maybe in X, maybe in DX, maybe in DX. Okay. Any other register. So this register after the XOR. So I have here a copy of CX. Okay, XORed with the value, the immediate value provided in the problem. When I XOR those, I will have a bitwise register that has 1 at the mismatch and 0 at the locations of the match. So out of this register, I wanted to count. So the problem is actually about counting, writing the program to make count the number of ones here in that register. If I count the number of ones in that register, that means I counted the number of mismatched bits between CX and the immediate value provided. Okay, how can I do that? Okay, here we can use, we need to count the number ones. So very simple technique we can use, again using the carry flag. Okay, so shifting, so moving or shifting, shift bit by bit from the mismatch or from step 2, okay, shift bit by bit from step 2 to the carry flag. That means the carry flag will take one of those bits here. Okay, if it is you, I want to accumulatively add it to some nullified register. Okay, if it is a 1, means I will add it on top of each other. So each value of the carry flag should be accumulated into some register. Okay, CX has how many bits? CX has 16 bits. So the maximum number that I have here is simply 16. So that means I can use any 1 byte registers in order to do this accumulation. So shifting the bits from step 2 into the carry flag and accumulatively add it to the counter of the ones bits. Okay, so the design of the problem is very simple. Okay, so now we can go to the coding. Okay, code implementation. Code implementation. As we mentioned, we need to copy CX somewhere, so I can use maybe AX. So move in, or maybe BX, move BX CX to take copy of CX. This is actually step number 1. This is step number 1. Okay, then second step is simply X or BX and the immediate value that he gave me in the instruction. Okay, now BX carry what? Carry the ones of the mismatched bits. The ones of the mismatched now in BX. Right now, I want to go into repeat a process for the shifting. How many times I have to repeat this? 16 times. Okay, so I have to do the following. First, I want to shift here, could be in any register. First of all, I want a register to accumulate the count. I need a register to accumulate the count. So I will move maybe in AL the value 0. So to clear AL register, to be clear. Then I will go into a process that I will repeat it for 16 times, shifting to any location, to any direction, in any direction, either left or right, shifting bx, 1. So now the most significant bit of bx will be shifted inside the carry flag. Okay, then accumulated to the AL. I have to add with carry AL and 0. AL originally have 0 and I will add it to 0. So effectively, AL will take the value of the carry flag. This is in the first step. I will repeat this 16 different times. I will repeat this 16 different times. Now shifting B again, okay, and add with carry AL, 0. Okay, so here those two instructions shifting, repeating this. Now AL equals to CF, the old CF plus the second bit, or actually, effectively, I can say that it actually equals to the BX of the, here is, which is actually the BX of the bit A, the bit 15. Bit 15 works. Here it is BX bit 15 plus BX bit 14 after the shift. Okay, and accumulatively, okay, I will repeat this. Okay, but this is one time, this is the second time. Okay, so those are actually step 3. Okay, let's say iteration 1, iteration 2, and I will keep repeating this. How many times? 16 times. Okay, as the iteration 16. Okay, that means I will have the same exact code, shifting to the left BX and add with carry AL, 0. Okay, at the end of the step, that means the value of BX 15 plus 10 plus all the I added up or aggregated all the values of the bits of BX together, which will give me the count of the number of bits that equals to 1 that are not matched between CX and the immediate value provided in the problem. So this is actually the solution for problem number 3, and see you after a little bit of break in solving problem number